of you who may not be familiar with the Water Center, we are an applied research center focused on identifying innovative and integrated solutions to all of our urban water challenges, both here in the US and around the world. We offer a series of programs and publications and welcome you to collaborate to explore the science, the politics, and the equity issues of urban water systems. Please reach out to us via our website, through social media, or just send us an email. And please note that this event is being recorded and it will be posted on the Water Center's website and in its social media beginning tomorrow. I'd like to turn over the microphone to Albert Slapp, the moderator for today's event. Albert.
Thanks, Howard. The class of 1971 is very pleased to co-host this webinar with the new Water Center at Penn. And the topic, climate change and global water crises, implications of too much and not enough water, was certainly very relevant when we were on campus in 1970 for the first Earth Day. And it's even more relevant 50 years hence. Personally, attending the first Earth Day celebration in Fairmount Park in 1970, when I was a junior in the college, set me on a 40-year career as an environmental lawyer and law professor, mainly representing environmental groups. Over the years, the class of 1971 has focused some of its fundraising efforts on the greening of Penn's campus, such as planting vegetation around our ivy stone outside the Annenberg School and planting a square around the Love statue in Locust Walk. While myself and our classmates are completely bummed out, very 60s adjective, that we can't have an in-person 50th reunion due to COVID-19, we humbly and recognize and appreciate all that our alma mater and its healthcare workers and renowned scientists have done and are doing to fight the pandemic and return our society to some sense of normalcy. We appreciate that. Today, we have three excellent speakers on this important and timely topic: Dr. Brian Soden, Dr. Scott Moore, and Howard Newkrug. In order to maximize the time available at the end for Q&A and audience participation, I'm going to introduce the speakers' bios. They'll each have about 10 minutes to present and then hand off to the next speaker. We should have about 30 minutes at the end in reserve for questions. So our first speaker is Dr. Brian Soden, who's a world-renowned climatologist. In 2007, Dr. Soden and others from the United Nations Intergovernmental Panel on Climate Change, the IPCC, shared the Nobel Prize with Vice President Al Gore for their efforts to build up and disseminate greater knowledge about man-made climate change and to lay the foundations for the measures that are needed to counteract such change. Dr. Soden is currently the Associate Dean for Graduate Studies at the University of Miami's prestigious Rosenstiel School for Marine and Atmospheric Science. And in full disclosure, Dr. Soden is also my Vice President of Science for the startup company Risk Footprint. Following Brian will be Dr. Scott Moore. Dr. Moore is a political scientist whose work focuses on water politics and policy. Scott's currently a senior fellow at the Water Center at Penn, as well as the director of China programs in the Office of the Provost. He's worked at the World Bank and the State Department, where he worked on the Paris Agreement on climate change, and I'm sure he's glad to see us back in the Paris Agreement. Finally, we'll hear from Howard, the executive director of the Water Center. He's also a professor of water practice at Penn. Howard's work focuses on reimagining our cities to become more water sensitive by balancing green and gray technologies and urban water management strategies. Howard was the commissioner and CEO of the City of Philadelphia's Water Department and is currently chair of the Delaware River Commission's Advisory Board on Climate Change. So without further delay, let me turn over the program to Dr. Soden. Thank you.
Thank you, Albert. I want to thank you and the UPenn Water Center for the opportunity to participate in this event. And I'm going to be speaking about the relationship between climate and the water cycle today. We can start with the next slide. So one thing we know about the climate is that it's warming. And this graph shows the change in global mean temperature going back to 1880. This is the instrumental record that we have over the past about 140 years. And we can see clearly that the climate in terms of the global mean temperature has warmed by about 2 degrees Fahrenheit. You can see the Fahrenheit scale here on the right. In fact, 2020, in addition to all the other things we'll remember it for, also is tied for the warmest year on record over the past 140 years that you can see here. And not only is this did we just go through the warmest year on record, the last decade has been the warmest decade on record, and likely the warmest decade in thousands of years, and perhaps as much as 120,000 years. And it's not just the temperature record, there's all sorts of other indicators that the climate is warming, sea ice is melting, glaciers are melting, and so forth. So the fact that the planet is warming is unequivocal. And we are living in, the climate we're living in today is a very different climate than what our parents or grandparents grew up in. We can use computer models to better understand the causes of this warming. And what these studies tell us is that the warming that we've seen over the last century is primarily caused by human activity. If we go to the next slide, we can also use those computer models to tell us what the future may look like. And on this graph, what it shows are again, the observed temperature record of global temperature over the past years, that's in green. And then black shows the computer model simulations of temperature over the last 100 years. And then the two colored lines show those computer model predictions for the temperature change over the next 100 years. And the two different colors indicate two different emission scenarios. A high emission scenario here in red, this is essentially where we keep burning fossil fuels as we have for the past century. And in blue shows a low emission scenario. The point here is that no matter which scenario you choose, the climate is going to continue to warm over the next century. And if we just kind of split the difference here, let's say we take about a 5 degree Fahrenheit change by the end of the century. That may not sound like much. And in terms of the water cycle, a good rule of thumb is that for every degree increase in global mean temperature, you get about a 1% increase in global precipitation. So for a 5 degree warming, we would expect maybe a 5% increase in global precipitation. And now that doesn't sound like much, and reality is it's not a lot. And so for example, if we take Philadelphia gets about 50 inches of rain a year. So a 5% increase in that would be maybe a 2 or 3 inch increase in rainfall by the end of the century. And if that amount of rain was just spread equally over the course of the year, that wouldn't be a problem. That wouldn't have a significant impact on agriculture or the built infrastructure. But unfortunately, that's not how the climate changes. And if we go to the next slide, we'll see that that change in precipitation doesn't occur uniformly. So this is what the spatial distribution of that 5% increase in precipitation looks like. And you can see the numbers here, the scale on the bottom, they're much larger than 5%. They're upwards of maybe as much as 50%. And then there's also regions that see a decrease in rainfall by as much as roughly 50%. So just because the global mean precipitation is only increasing by 5%, how that precipitation gets distributed spatially is highly variable. And so again, in the Northeast US, that 5% increase in global mean precipitation is maybe closer to a 15 or 20% increase in precipitation in that region. And that starts to become a significant amount of change in precipitation. The other point to make here is not only is the amplitude of precipitation very highly variable and much larger than that global mean, but this pattern of rainfall change tends to reinforce what we already experience. And by that, I mean that regions like in the deep tropics that are already get plenty of rainfall will get more. And regions in the subtropics, where most of the world's deserts are located, will get less. So even though the global mean precipitation increases, what happens is that wet regions become wetter and dry regions become drier. Now, even more significant than this, if we go to the next slide, is that not only is the precipitation change not equally distributed spatially, but it also doesn't happen uniformly in time. So again, if we consider Philadelphia, right now Philadelphia gets about 100 days of rainfall, and a sort of a 5% increase on that would be 5 more days of rain. Again, if the change in precipitation happened that way, that wouldn't be a significant cause of concern. But just like it's not spatially distributed uniformly, that change in precipitation also doesn't occur uniformly in time. And what these two maps show on the left are the changes in maximum rainfall rate, maximum 5-day precipitation. And on the right are the number of consecutive dry days. And so what you see is that how that 5% increase in precipitation gets distributed through time is that when it does rain, the rainfall is more intense by upwards of 20 to 25%. And then in between those rain events, there's longer stretches where it doesn't rain. So there's longer dry spells. And so what this does is it amplifies the extremes in the water cycle. When it does rain, the rainfall is more intense, and the time between the rain events becomes longer. And that increases our vulnerability to both extremes in terms of their societal impact. It makes us more, the frequency of flooding events more common. And in between those flooding events, it makes the frequency of droughts more common. And this happens pretty ubiquitously. So even places that experience a decrease in the annual mean rainfall still have that rainfall delivered in more intense thunderstorms, more intense rain bursts. And even places that may have an increase in mean rainfall will also experience longer durations of dry spells in between these rain events. So that summarizes the key points that I wanted to make in terms of the connection between a warming climate and the changes in the water cycle. And now I'll turn it over to Scott.
Thanks so much, Brian, and good afternoon, at least on Philadelphia time, to all of you. Many congratulations on your 50th reunion. I am, as you might have guessed, unfortunately not speaking to you from campus, from Levy Park, but Fisher Fine Arts is my favorite building on campus, and so I like to use it as my background to remind myself of what it's like to stroll through campus on a nice day. And I hope it evokes some more memories of being on Penn's campus for you too. Certainly, I hope that we can all go back before too long. My kind of task here in this session is to offer a little bit of a social science perspective. As Albert mentioned, I'm a political scientist by background. And one of the things I've gotten really interested in over the last few years is the nexus or the relationship between water, climate change, and conflict. And so I'll just talk a little bit today about some findings from a book that I came out with a few years ago. Next slide, please. And I wanted to actually begin by sort of trying to pick up where Dr. Soden left off in terms of giving us such a thorough overview of the hydrological impacts and dimensions of climate change, and to overlay some of what we're seeing in terms of those hydrological changes with some anthropogenic effects on our water resources that are not directly climate related, although there are certainly linkages. What this map shows is about a decade of observations from a satellite called GRACE. This was a satellite that was launched in 2002 And what it allows us to do is to look at large-scale fluxes in terms of what's happening to the world's water at global and large regional scales. And the thing that's really interesting about this, and what makes this, I think, such an important image when it comes to thinking about what's happening to the world's water, is that really before these observations came online and before we were able to get data from remote sensing platforms like GRACE, really our sense of what was happening to the world's water was based more or less on taking a lot of point physical measurements of things like stream flow, of precipitation, and then using that to sort of model what we thought was happening at larger scales. What this satellite platform allows us to do, and there are other remote sensing platforms as well, but what this allows us to do is to sort of see what's happening to the world's water at these very large scales. That's especially significant for groundwater because, again, it was something that was really difficult to measure and to track before the advent of these remote sensing platforms. So what you see in this image is really three different signals. Two of which are the same ones that Dr. Soden talked about in broad terms. You see a pretty significant loss of ice mass at the poles and in sort of the high mountain ranges, the Himalaya, the Andes. By the way, in this map, blue is gain, is sort of a positive trend in terms of the mass of water that the satellite is tracking, and then red is depletion or loss. The second signal that you see are shifts in precipitation and water availability patterns, especially in the kind of mid-latitude regions. Some of those are probably linked to long-term climatic changes, others are natural variation. And the third and final thing that you see, and the one that I really want to focus us on, is essentially groundwater depletion. Those are those big red blobs that you see in places like the U.S. Southwest and sort of broadly speaking, the Texas region. You see them in northeastern China, South Asia, the Middle East, and North Africa. And what's interesting about that signal that you see is itself twofold. One, that's more or less a straight up case of unsustainable, poor water resource management. When you see that scale of depletion, that's almost always over withdrawal of groundwater, meaning that you're taking more out of underground aquifers and sources of water than is being naturally replenished through precipitation or other processes. And then the second thing that's notable about that is it's not like that phenomenon is evenly distributed around the world. If you just sort of take a look, disproportionate impacts in very fragile or conflict-ridden parts of the world, like the Middle East and North Africa, and in really large economies and countries and regions that are very geopolitically important, like China, like South Asia, like the United States, and like Brazil. And so as a political scientist, what interests me is that kind of intersection of these global effects on our water and on hydrology and that kind of geopolitical and political kind of layer. Next slide, please. So that then leads me as a political scientist to think about what this might mean for conflict and especially for warfare. And certainly there's no shortage of kind of prognostications from eminent people over the last couple of decades that have kind of fallen under the general category of looking at changes like those depicted on that map and predicting that it's going to lead to an increase in conflict of some form. Probably the most famous of those kind of predictions is the one in the middle of the slide here, that the wars of the next century will be fought over water unless we change our approach to managing this precious and vital resource. That was a prediction or a statement that was made by a former World Bank official in 1995. The first half of that quote is the one that's most commonly repeated But it's the second half of the quote that I think is actually most pertinent, because really what the graph and the map that I showed in my previous slide indicates is that, if anything, our approach to managing this precious and vital resource of water has actually gotten worse, or it's certainly not improved to the point where we could say that it's become sustainable. And so that then I think makes this question really interesting to reflect on. What can we expect in terms of the prospect or incidence of conflict and warfare as we see these linked climate and water changes accelerate? And just to kind of give a brief summation of some of my research and what I think is kind of consensus that's emerged in the research done on this topic, actually less than you would expect. There are very, very few incontrovertible or clear cases where countries have fought or engaged in any kind of organized violence over water. There are, however, lots of examples of conflicts of many kinds, some of which involve violence, most of which do not, and are more kind of rhetorical or political, that happen over water within countries. So disputes between states, provinces, communities over not just water quantity, but also things like water quality, the building of dams or canals or other water infrastructure, water pricing. So what we seem to find is that while water can be very contentious, it actually doesn't very often result in any sort of organized violence, and certainly not warfare. The other thing that I think is really interesting that I certainly found in my research, and that I think has been borne out by other research as well, is that while water can be very contentious and certainly can lead to forms of conflict, it actually just as often, if not more often, provides a catalyst for cooperation, and at many different levels, both between countries where you'll have different agreements that have been that are signed to cooperatively manage shared waters, as well as between communities and other types of social groups. And I'll just sort of say briefly that one case I look at a lot in the book, and that I think is very interesting to follow for those of you who may be interested in this topic, is the case of the Colorado River Basin in the US, the site of lots of long-running legal battles throughout most of the 20th century. But really starting in the late 90s and continuing into this century, a lot of really amazing examples actually of cooperation between state governments, between water users of many different kinds, and between the US and Mexico, the two countries that share the Colorado River Basin. So I think in many ways, from a kind of conflict standpoint and political science standpoint, is actually sort of a hopeful story here. Next slide, please. However, and this is where I'll conclude and hand things over to Howard, there's a lot to be concerned about in terms of that unsustainable aspect of how we use our water. And even as the sort of conflict and international relations piece of this puzzle is, I think, maybe a little bit less worrisome than some folks may assume, the economic impacts are very severe, and as is the kind of overall social implication. I was part of a study when I was at the World Bank where we tried to look at the impact of different water management strategies on GDP growth throughout the developing world. And basically what we found is that continuing on the current path where in virtually all countries, water is, a lot of it's wasted, it's very rarely devoted to its highest value economic uses. It's a drag on GDP growth of typically somewhere between 2 and potentially as much as 6% per year. If we were to shift and adopt more sustainable water management practices, we could actually generate net positive returns to GDP growth throughout most of the world, except for the Middle East. And you see that on the right-hand side of the graphic there, which gets to my last point, that there are parts of the world where water is so serious an issue and where sustainable management is such a challenge that even with adopting some really ambitious policies, it's still uncertain whether we can realize what you might call sustainable water resource management, particularly given accelerating climate effects. Given that this is already a very unstable region, there are a lot of concerns going forward about mass migration that partly could be due to water scarcity and other related stresses. So there are lots of concerns here, but I think broadly speaking, this is a problem that is centered on economics rather than kind of politics and conflict per se. And on that note, I will hand things over to our Executive Director, Howard Newcomb.
Well, thank you, Scott and Brian and Albert. You know, I wasn't going to start with, I wasn't even going to go there, but Scott, first of all, we did not pre-plan this, but our talks go very well together. And but I just, when you were talking about conflicts, I remembered Mark Twain saying, whiskey is for drinking and water is for fighting over. So just to throw that out there, and I'm hoping that I took a good news perspective on climate change and its impact on our urban water systems. There's plenty of bad news out there, and I'll explain that. But you know, it's we're really talking about, and we're talking about two different things when we talk about mitigation. How do we stop this? And very much that's what President Biden is working on and has rejoined the Paris Accord in order to figure out how the world can mitigate, lower the carbon dioxide levels so that you can really go after and stop the kind of changes to the climate that are expected. On the water business, we're really, and next slide, please. We're really looking at something a little different. We're really looking at adaptation. And I borrowed this slide from my good friends from DRBC. I see they're on the call here today. So I hope I have your permission to use this slide. But I just found it so perfect in terms of like, where do you start? So we're going to talk about climate change and we're talking about water. And you look at this and this is all, you know, it's all out there. It's all, you know, and everything here is an impact of the fact that climate change is happening. These are the impacts on water. And these are the things that the water business is looking to see, how do we deal with these over the next 50, 100, 1,000 years. And you know, you take any one of these and they become big significant issues. I'm just going to take the good side of two of them. One is flooding and one is droughts, and go to the next slide. And I'll state that good water policy is good climate policy. And the graph on the three graphs on the left-hand side, the top one is how important for federal government is it for the federal government to address climate change? And because we're in a political season, well, maybe we're in a political year or a political decade, this survey was based upon, from the left-hand side, strong Democrat, to the right-hand side, strong Republican. And what you see is that federal government involvement in climate change is something that the Democratic leaning folks are very much in favor of. Not so much for on the Republican side. And that has caused a lot of conflict, obviously, over the last number of years. And then the second question was, how concerned are you about chemicals and pollutants in drinking water? And all of a sudden, everybody has the same kind of concern. And the third question is, how much are you concerned about chemicals and pollutants in local waterways? And you see, again, it's the same kind of numbers. So when you're talking about climate change, sometimes it's good to talk about water and the water issues. And if you care about the planet more than you care about branding, talk less about carbon dioxide and more about H2O. And that might be a little bit overstating it a bit, but it's really talking about, you're talking about water and you're talking about climate policy, really you're talking about adaptation. Next slide, please. So I thought I'd give you a number of examples of adaptation. I'm showing a couple from Penn and back from, I'm an alumni from 1978. And so I know this well, I'm sure you do too. This is the parking lot for the US Post Office that had its main headquarters here at the time. And this was a real eyesore, and clearly it prevented so many things from happening that were good. And what Penn did was really tremendous here. They took this 100% impervious covered area, and next slide, please. And they built Penn Park, Many of you have probably been by here and seen it. But basically, it was one of the first projects in Philadelphia to use green stormwater infrastructure to absorb the water, store the water, reuse the water. This was the product, and became something of a real benefit to certainly the Penn community, but the larger city itself. And it took 24 acres of impervious cover and is now managing the 1.5 inches of rainfall. Up to 1.5 inches of rainfall is all being managed here. So you can start to think about, wow, if you can do that more in the city, you can really come up with something. So next slide, please. I wish we were all together so I can just ask the class, what is this? And I'm sure everyone from the class of 71 will know that these are the tennis courts down by the stadium. And this was the tennis courts down by the stadium, and all impervious. And next slide, please. And now it's Shoemaker Green, and it's one of the greenest spots on campus. Please visit it when you come back to Penn. And it has stormwater management in many different ways. I don't have sufficient time to tell you all the different ways that water is being managed here, but it's one of the best sites in the country in terms of innovation and creativity in managing stormwater and also providing green space. Next slide. And furthermore, just just talk about Philadelphia in general. It's approaching the year 10 of a 25-year program called Green Cities, Clean Waters, and it's really about taking 10,000 acres of impervious cover in the city of Philadelphia and greening them and managing stormwater on them and managing flooding and overflows of sewage into the rivers. And just a great example of what's really happening now all over the country and all over the world. So next slide, please. And here's here's the room for the River of Val, and this is again just an idea of what's going on in Europe. It says for 800 years, this is the Dutch. We have built dikes higher and higher, but if something goes wrong, the damage will be greater. We need to remain flexible in adapting to climate change. So now we try to remove the bottlenecks. The river will run through the city instead of along the city. And what you see here is the River Val, and with the bridge going over it. And then this piece of land that was a highly floodable piece of land, because this becomes a bottleneck because of the turn in the river here. And instead they're building, if you look at the top right image, a water channel so that you can manage the water, create the city, build the city out to the banks, create a parkland in the small piece of stretch of land between the river and the channel, and live with the city and have the river run through the city and redesign the city and move. And you can't really see it here, but they actually moved the dike far inland. And so it's no longer needed at the edge of the water. Next slide, please. And this is in Rotterdam. And what you see here is a basketball court, and it's a sunken basketball court, and it's attractively painted. And I wish I had the wet weather picture, but that basketball court is also a stormwater detention basin. So when it rains, that basketball court gets wet. It doesn't only get wet, it gets filled with water, becomes a source for protecting the area by managing stormwater in this whole impervious area, this whole shopping center. And again, you look at this and you go like, oh, wow, there are ways that you can convert cities into areas where water is managed in a much better way than it's been for the last 100, 150 years. Next slide, please. This is Singapore, and this is pretty self-evident. 2008, this is a typical around the world way to solve excess stormwater and flooding is to build a concrete channel and allow the water to move as quickly as you can away from people and bring it to the river. Unfortunately, what happens then is that there's more and more flooding that's happening downstream. And now the newer designs, of course, are looking more at the green stormwater infrastructure where you're managing the land and you're giving a place for the water to go. And you're also giving a place for people to recreate when it's not raining. Next slide, please. And just some other examples. This is I just love this photo. That's why I'm showing it. But it's a company called Plenty, which is doing agriculture on a vertical surface, making green walls and using significantly less water and pesticides and creating nutritious lettuce. And it's it's the way of the future, and there is hope that we will be able to find other ways to do agriculture and to feed our society. Next slide. And just looking at one other aspect of this, because I've been talking about the flooding, and I showed the ag photo, but now I just want to talk about desalinization, also called desalting. And this is interesting because this is I'm also picking on the Middle East and recognizing the things that are happening in places like Saudi Arabia and Egypt. And this is a desal plant in Saudi Arabia. And what's notable about this is, one, how many they're building; two, that they're doing it in a way where they're beginning to use renewable energy in order to run these facilities, which are very expensive to run because of the amount of energy that's needed. And also that they've recently put out some proposals for bids. And we're finding that the price of desalinization has dropped dramatically over the last number of years and is still declining. Next slide, please. So this is my last slide, but it's just so indicative. Here's Egypt, and all of a sudden they're building desal plants, and not just a few. You can see they're building I forget how many, but it looks like about 100 desalinization facilities over the next 30 years, and spending quite a bit of money to do that. And you can see they almost all their waterfront will be filled with different types of desalinization, different types because it's different types for different needs. Certainly, phase one is about potable water needs for the existing organization, the existing population, and then if you go down to item 4, phase 4, that's water needed for new development. So I guess what I'm saying here is that maybe we in the water business can figure out how to manage some of the issues of flooding, and maybe in the water business we know that desal, and with desal and pipes and renewable energy, you can get water from the ocean very easily, and you can send it anywhere in the world. So we're not there yet, and the costs are incredible, but with man's ingenuity, I think we have a good place to go into our future, and that we're all working in that direction. So I'll leave it at that, and I will suggest that we have a Q&A box, and please, if you have any questions for any of us or comments, please put them into the Q&A box, and I'll turn it back to Albert.
Hold on. Okay, well, thank you very much to Brian and Scott and Howard. Those are really great presentations. I'm going to kick off the Q&A with a couple of questions, and then we'll go to the questions that have come in through the chat. The first question goes to Brian, and sometimes when issues of CO2 mitigation and adaptation are raised, I hear this. If we were able to stop burning all fossil fuels tomorrow, that enough heat is baked into the oceans that we're still going to have untoward effects, such as sea level rise and some of the things that you mentioned, regardless, until some time in the future. I wonder if you could just briefly address that is that scientific, and what are your thoughts on that?
Yeah, that's absolutely right, Albert. The issue is that the Earth is out of balance. We're not emitting enough energy as it receives, and so since it's gaining more energy than it's losing, it's going to continue to warm up until it can restore that balance. And you know, the estimates are that, as you said, and this is completely hypothetical, well, not hypothetical, but completely pie in the sky. It's unachievable that if we were to cap CO2 levels at today's value, not CO2 emissions, but the actual levels of CO2, there would still be another 1 to 2 degree Fahrenheit warming that is already, as you say, baked into the system because we're still trying to catch up and come into balance with our past emissions of greenhouse gases.
Okay. So if sea levels are going to rise, and they're baked in to some extent because of the heat sink in the oceans, a quick question for Howard is that demographically we have so many millions of people moving into the cities, and you know, even if we have desalination plants or whatever the infrastructure is so close to the oceans and they're rising, how do you see that working out?
Well, thank you for that question, Albert. And you know, I've been trying to stay on the optimistic, positive side. The thing that I haven't really figured out how we adapt to well yet is the sea level rise, which is going to affect almost almost all countries in the world and cities. And basically the answer is people are going to have to adapt. Not water. The people are going to have to adapt to where the water's now going to be, and people are going to have to move. And we're going to have to be thinking about how and when we rebuild along the coastlines. Very significant issues, and there are many other aspects of sea level rise that are of concern, particularly in the Philadelphia area, where we're concerned about salinity. As the sea level rises, more salt water comes up the estuary, and it approaches our drinking water supplies, which may force us again into the desal solution if we can't find additional pockets of water to send downstream and keep the salt water at bay. And finally, you know, the other issue that I've just learned about recently is the freshwater marshes along the Delaware, that as more and more brackish water moves upstream, you're going to start to change the aquatic life nature of the marshes, and may destroy them, may just change them. We don't really know at this point, but a significant issue.
Great, thank you, Howard. A couple of questions for Scott. I'm going to group two audience questions together. So one question was, can you provide some examples of conflicts that have happened due to water up to now? And then one has to do with a news story about new satellite surveillance of the Mekong River in China. And given China's reluctance to tolerate what they perceive to be outside interference with internal policies, do you think the new surveillance capabilities will increase the potential for conflict between China and Southeast Asian countries who are below China on the course of the Mekong? So I don't know, you know, those two go together, but just trying to give you some things from the audience here.
Yeah, sure thing. And I actually typed just a brief response in the box, along with some links for anybody who's interested in following up. But just kind of briefly for the benefit of the audience as a whole. So there are some, you know, there's certainly some arguments you could make about cases, but my argument in return would be that that there are no clear cases of interstate warfare or really organized violence over water in the modern period. And the further back you go, the less, the less clear cut the cases become. So I would say that there are very few, if any, actual cases of that. However, if you wanted to, well, let me make 2 points, one of which addresses the latter question. That's not to say that water isn't the source of enormous tension between countries. And you see that all over the world, including in the Mekong, which, yeah, I do think that is, that's a place where we're going to see growing tension over transboundary waters. But, my kind of reading on most, if not all of those situations where you have this tension is that there are a lot of other things going on here that are related but distinguishable from water. I don't think you would have tension over the Mekong if you didn't have this massive power asymmetry between China and its neighboring countries. I think in many ways water becomes this like lens that magnifies these pre-existing geopolitical tensions, most of which have roots in things that are distinguishable from water itself. So that would be my response to that kind of general question.
Brian, there was a question from Tom O'Hara about carbon capture and removing carbon from the atmosphere. And, we hear about that and it's in the newspaper, but from a science standpoint, has the scientific community, to your knowledge, or at the UN level, IPCC, provided us any thought of whether this is scientifically feasible and in what time frame, or there's just not enough information yet?
Well, on things like the direct carbon capture, where they capture the carbon at the source of the emission, like at the coal plants, I mean, that's feasible. Whether or not it's scientifically doable, whether or not it's economically feasible, maybe that I can't really answer that question. But there is a broader field of research called geoengineering, which looks more broadly at how we can sort of intentionally modify the amount of warming, and that doesn't. There's a lot of scientific research on there. There's certainly, I don't think, any kind of consensus about the best ways of doing that and if we should do that. And that involves there's a variety of different mechanisms for doing that, such as injecting small particles into the stratosphere so it blocks and filters out some of the sunlight and cooling it that way. Most, if not all, of these different types of geoengineering things have other known consequences and probably other, more worrisome, other unforeseen consequences. So there, I would say there isn't a lot of enthusiasm about having to get to these things. They're more of a last resort if we get to a point where the amount of warming is simply unsustainable, that we have a way of trying to mitigate it.
Great. We have another a question from, some of these are coming to the chat and some to the Q&A, but from Don Picano. What about ocean acidification, and how does that play into this? And maybe that's both a question for Brian and Howard. Does that have anything to do with the oceans being out of balance and desal?
Brian, would you like to start?
Well, I can say quickly, yeah, as we increase the amount of CO2 in the atmosphere, it just doesn't stay there, but it also goes into the ocean, and that increases the acidity of the ocean and makes it harder for things that have calcium carbonate shells or skeletons to form. So coral reefs in particular are an example of something that's vulnerable to this. And they're also vulnerable to the warming. So it's just an example of, one of the really serious ecological threats that climate change has, both in terms of altering the chemistry as well as the warmth of the ocean.
from a water treatment perspective, very much so, pH and alkalinity have a big impact on the quality of the water and the ability to treat. Fortunately, we have very good ability to adjust the pH and alkalinity, both coming out of the ocean, going into a reverse osmosis system, and also leaving that system. So it's a problem for many reasons, dealing with the ocean. But when it comes to the desalting process, it can be handled. And there was another question on the board there about junk in the ocean, and how isn't that going to get in the way of desal? And again, there's a number of different types of filters, and sometimes you have 2 or 3 stage filters. Whatever is the least cost to get the cleanest water that you're looking for is there are mechanisms to do it. And really the issue again comes down to cost.
Great, thank you. From one of my classmates, John Chester, he said, and this is something that back when we were on campus, we used to hear a lot about population control and ZPG, zero population growth. He says, isn't population control essential to solve both the climate and water problems? It's interesting that we don't hear that much about population control anymore. I think maybe it's not politically correct, or we just don't hear it. But what would the panelists, maybe Scott, you could start with that and then hand it over to the other panelists. I think it's a really fascinating point myself.
Yeah, so it is a really kind of, you're right that it's sort of a question that doesn't come up all that much anymore. But certainly if you were to go back to the 70s, virtually all discussion of global environmental problems revolved around this question of population growth and whether we're able to, to kind of sustain it resource-wise. I guess maybe just as a few quick points, the population growth kind of argument is probably the best example of like Malthusian, kind of Malthusian view of the world, where like at some point you just kind of run out of resources to feed the kind of number of mouths that we have, both literally and figuratively. I will say, historically at a global level, that has not proven true ever since Malthus himself first kind of posed that in the 18th century. So, historically speaking, and at a global level, that theory has a pretty weak track record. That's not to say that there's nothing to it. And I think where it, what is significant is to look at demography as kind of a predictor and a big variable in terms of what it implies for our resource use. What I would say though is that it's not really so much the sheer number of people that's significant about demography. It's kind of how that population breaks down and how patterns of life translate into resource use. There's a lot more I could say about that, but just for the sake of time, what I mean by that, to boil it down, is that one American or Canadian or Australian, in terms of resource use and kind of impact on the planet, is the equivalent of maybe dozens, if not even more, of someone living in a much more marginal environment or country or society with a much lower level of per capita resource use. So there's a lot of, I think it's best viewed in qualitative than quantitative terms, is I guess what would be my response.
That's hard to follow, Scott, but to me it boils down to in the 70s we were probably talking about mitigation more, and mitigation, you're going to stop using fossil fuels, or you're going to use your cars less, or use more efficient cars, or you can have less people. And those seem to be the options out there. And in terms of mitigation to the future, I hope that there are strategies out there that are better than restricting people's ability to procreate. In terms of adaptation, it's kind of it's a little bit different. It's we're gonna adapt or we're gonna die, And it's as you know, so in some sense, we will take care of, nature is going to take care of that problem on its own. Hopefully we are going to adapt. I believe we're going to adapt, but there will be a relationship between population and our ability to adapt to the changes.
Well, that's Howard, that's a great segue to the next question from anonymous attendee who asks how to make sure that climate adaptation efforts are inclusive. Do decision makers consider demographic data, especially informal settlement in developing countries? But I would just say that, you know, environmental justice and how our resources and policies have been playing out here in the United States, in especially communities of color, in environmentally risky areas, Native American reservations and settlements are really on the if you will, the tip of the spear down in Louisiana and up in Alaska. Perhaps, you know, Scott and Howard and Brian, you could just talk a little bit about how we're going to deal with the fact that there's not everybody's going to be a winner. Not everybody's going to survive what's coming at us.
I'll just start there and talk about all the changes that have happened in the last year. I know to me personally and many others as the Black Lives movement has taken hold, and people are reflecting on what they're doing, and programs like the Green Cities Clean Water program in Philadelphia is very much, it's about diversity, equity, justice, and inclusion. And because, you know, what we're doing is taking money that otherwise you'd spend on big tunnels and walls, dikes, to protect yourself from the environment. We're instead spending it on the surface and looking predominantly at the less advantaged communities, because that's where a lot of the damage is. That's where a lot of the homes without trees in front or in the back exist, and all those things need to change. Just need to bring a little bit more nature into our inner cities, and a great place to start is in disadvantaged communities.
Yeah, I'll just briefly respond and add that I think that particularly with water among resources, you know, I think the issues of equity and of justice are really salient. I mean, they certainly should apply to any kind of resource allocation question, but just by virtue of the indispensable role that water plays in health and in just basic survival, you sort of have this this inherent component that I think is a lot more poignant than in the case, and certainly more pressing in many ways, than is the case for some other resources. And the other kind of related, I think, point to that is that another distinguishing characteristic of water is it has this kind of social, cultural, even religious resonance that not many other resources have. You know, I don't think, to my knowledge, there are no sacred oil wells, but there are certainly plenty of sacred springs and rivers and streams around the world. And just to pick up on something that you said, Albert, I mean, one thing that is unfortunately very common, if not near universal across countries, is that marginalized populations, and especially indigenous populations, get cut out of whatever system exists to allocate water. And that's certainly true in the US, where Native American water rights were essentially unrecognized. I mean, despite having treaties and having laws that guaranteed certain usage rights to Native Americans, they were literally ignored by the courts. I mean, and really, in some cases, until the 1990s. So that kind of, those equity and justice dimensions are really profound when it comes to water, and they sort of seep into all parts of the water puzzle. I think, you know, quality in terms of things like light contamination, things that Howard's done a lot of work on, and also kind of over into the quantity and allocation issues. And then finally, just to underscore something that Howard said about protecting different populations and communities, one reality is that in terms of adaptation to climate change, we are not going to be able to afford to protect anywhere near you know, all of our communities. And so the question becomes who and what, and kind of what, you know, what types of communities do we invest the resources in to build seawalls, to build levees, and that kind of thing. And that's a really profound and difficult distributional question.
Thanks.
If I could just add out,
Oh, yeah, sure.
because, I should mention that earlier today, the Water Center had a webinar where we featured Mike Webster, who's the executive director of Cape Town Water, and part of you know, they were near no water, out of water as day zero several years ago, and now they have this 20-year plan to make sure that they have sufficient water supplies no matter what happens to the environment. And it was quite heartening to hear him talk about the significant amount of informal settlements and the compassion, empathy that the water systems have to making sure that they are a part of these changes that are going to happen for their sanitation systems, their waterways, and for getting drinking water. The difficult part of that is understanding how that all fits in with how that all fits in with other things like housing and transportation and jobs and poverty and education. And one of the big things that the water industry is looking for right now is how to leverage, how to co-partner with others and other parts of government to make full change rather than just each siloed part of our society making changes on their own.
Thanks. So there's a question here from David Carson about conflicts within the United States over water. And he says, do you see notable conflicts coming down the pipeline and in the US? And of course, that made me think of the cancellation of the Keystone pipeline. But I wonder if the pipeline or pipelines can be reprogrammed from bringing oil from oil sands in Canada to bringing fresh drinking water from places up north that have perhaps enough or too much water to areas in our Southwest that don't have enough water. And that I'd also like to bring in another question that one of the audience asked about: what should the Biden administration's key policies be? There's obviously going to be a push for infrastructure and the quote Green New Deal, whatever that means. But the question is, there's a lot of infrastructure needs, from railroads and bridges and highways, and then there's the water infrastructure. So how should we be thinking about the priority of water and water infrastructure in the competition in the United States for the infrastructure dollars?
Well, I'll just take the part about President Biden and what the water business in the U.S. is looking for. And I think you nailed it, Albert. It's very much what's really needed in the U.S. right now is just basic dollars to bring our infrastructure, our water infrastructure, back up to some basic level of sustainability. It is a very good sign going on. There's a good friend and colleague of the Water Center, Radhika Fox, who has been running an organization called the U.S. Water Alliance, has just been named the director of the Office of Water for EPA. And I can tell you that I don't know what the Biden's philosophy will be, but I know what her philosophy is, which is very much based upon issues of equity, of decentralization of water systems, of taking, moving us along in a more equitable way to managing water in our urban centers. So there's a lot of, to me, there's a lot of hope with her appointment that's really ringing loud and true as to what the Biden administration be looking to do.
So Scott, we're kind of almost out of time. We have a few more minutes. Do you want to say a few words about that, and then we'll hand it over to Howard to wrap up?
Sure. Yeah, just to answer the kind of the water conflict and sort of transfer questions. It's a really interesting. The Keystone XL thing is that's a super interesting suggestion. I imagine that technically speaking that might be possible, but it would never make any kind of economic sense whatsoever. And that does lead to an important point. Water is one of the most undervalued resources that we have. It's actually one of the cheapest liquids that there is. Certainly far cheaper than petroleum, or refined oils per unit volume. And that's something that I think in terms of how we actually make water management sustainable, we do have to tackle, because not only does it encourage profligate and sort of nonsensical ways of using water, but it also deprives utilities and governments and other sources of funding for the infrastructure improvements that we need. So some degree of water pricing reform has to be part of the solution, not just in the US, but globally. While recognizing all of the equity issues that are there, and there are ways to balance those two considerations. Philadelphia has been among the, I think, the leaders in trying to do that. Very quickly on the sort of water conflicts question, yeah, an increasing number, and what's interesting over the last 15 years or so, or 20 maybe, is that most of the water sharing conflicts in the US previously were confined to the West. Makes sense, less to go around, but they've spread. And so now one of the biggest such conflicts is in the Southeast, between primarily Florida and Georgia, with Alabama also in the mix there. So you have, and that's really just a reflection of urbanization, growth of the Atlanta area in particular. So you're seeing a kind of proliferation and a shift in geography, which I would say is not unrelated to some of the climactic shifts that we're seeing as well, alongside urbanization and other trends.
So we have time for one more question, and then Howard will wrap up. So another one of my classmates, Robert Kosian, who lives down in Charleston, has a whole lot of sea level and other problems, says the Army Corps of Engineers has proposed an 8-mile wall around Charleston as a mitigant to storm surge. Why is the Corps so far behind the issues that we've been talking about? Why is it taken them so long to figure some of these things out? I don't know. Howard, do you want to grapple with that one?
Well, first of all, I don't know the situation in Charleston. So it is possible a wall will help for 100 years or so, but as my friend in Rotterdam said, you build a dike, you then have to go back and build it bigger. And every time you build it bigger, eventually nature's going to win, and you can have a really big flood, and people are going to die, and it's going to be very tragic. So it's not, at least on its own, it's really not a long-term solution. No, we've seen that in the Netherlands, and but the Army Corps is very good, but they, excellent engineers, and but they're funded to build infrastructure, and I think what we're saying is that the next level of infrastructure has to be done in a very different way than it's been done in the past. and we need to relook. And what I usually say is that it took us 150 years to build the infrastructure, water infrastructure system that we've built. It's going to take us 150 years to figure out how to rebuild it in a more sustainable and resilient way.
Good point. Good point. Thank you very much. So we have another couple of minutes. Howard, I'm going to turn it over to you to sort of wrap up and give us your final thoughts and plug for the Great Water Center and all that you guys are doing. I wish that there was a water center at Penn when I was there. That's for sure.
Yeah. Well, thank you, Albert, and thank you for moderating today. As I well know, it's not an easy job. You have a lot of questions being thrown at you, and you got to balance everything out. You did a wonderful job there, so thank you very much. And of course, to Scott and to Brian, excellent. You're just great thoughts, and I can't believe if there was anybody listening today who hadn't learned at least one thing, if not 50 things. New things today. So thank you all for that, because it was really great dialogue, and look forward to working with you all in the future. And to the audience, thank you for participating. Remember, the program is being recorded, and you will get and it'll be available on our web starting tomorrow. You can send it to your friends. Take a few minutes. You'll get an email with a feedback survey, and I hope that you can all fill that out and return it. That's how we make our shows better and better. Hidden behind the scenes here is Meg and Crystal, who have really put this whole thing together for us. And again, that's not easy either. So thank you guys for doing that. And thanks everyone again for a terrific discussion and some great questions there. Thank you.